Good day everyone. Taking ahead our stability series, in this video we will learn a stability aspect called list. Also with the help of numericals we discuss to solve the conditions where vessel is initially at upright to finish upright after loading or discharging operation. Second, when vessel is upright and finishes at certain degree of list. Third, when vessel is at certain degree of list to finish upright. And fourth, when it starts at certain degree of list and finishes at another degree of list. Now let's discuss. If a ship loaded and discharged cargo from different places from both sides of the ship, the center of gravity of the ship will move from G to another point in another place, port or starboard side, such as G1. The ship will list to the side where G moved with an angle theta due to a moment equal to W into G1 G2. The center of buoyancy B will move from B1 where B1 will be below G1 and M as shown in the figure. The vessel will finally listed with an angle theta and will roll around this angle if heeled due to an external force. Now the figure ahead shows the actual condition in which the vessel will be when listed, that is the W acting directly below meta center from the point G1 and B1 directly below G1, creating an angle theta. So the vessel will be finally listed with this angle theta, and center of buoyancy acting from point B1 will pushing upwards and W displacement pushing the vessel downwards, keeping it in this listed condition. Now the vessel will roll around this angle theta if heeled due to any external forces. Now let's find out how to calculate this angle theta. From triangle M G1 G2, the angle theta can be calculated as tan theta is equal to opposite by adjacent, that is G1 G2 divided by G2 M final. We know that Km is equal to Kg plus Gm. Therefore, now Gm final is calculated by calculating Kg final and subtracting it from Km. G1 G2 can be calculated by calculating moments of all the weights about the midship and dividing the final moment, which is the difference between the port moment and the starboard moment, by the final displacement, and the direction of G1 and angle theta will be to the side with more moment. This means after loading and or discharging operation, whichever side the weights are more, the ship will list to that side with angle theta and G1 in the same direction. So let's discuss case number 1, when ship starts upright and ends upright, with an example. A ship of 5600 tons displacement is floating upright. A weight of 30 tons is lifted from port side of number 2 twin deck to the starboard side of number 2 shelter deck 10 meter horizontally. Find the weight of water to be transferred in number 3 double bottom tank from starboard side to port to keep the ship upright. The distance between the center of gravity of tanks is 6 meters. So as in diagram we see 30 tons is shifted from port to starboard side horizontally at distance of 10 meters. Now we have to find W, the water which has to be transferred from starboard side to port side to keep the vessel upright. The distance between the center of gravity of double bottom number 3 double bottom tank from starboard to port is 6 meters. So in this case the vessel was initially upright, then 30 tons was shifted, so we need to shift some ballast so that again the ship ends with no list, that is upright condition. Hence we can say that for this the starboard moment should be equal to port moment, that is 30 into 10 is equal to W into 6. Thereby we get the value of W is equal to 30 into 10 divided by 6, that is equal to 50 tons. So 50 tons of ballast needs to be shifted from starboard side number 3 double bottom to port side number 3 double bottom tank to keep the vessel upright. So now case number 2, the ship start listed and ends upright, that is initially it is listed and then we have to make it upright. So the example, a ship of 13,750 tons displacement, GM 0.75 meters, is listed 2.5 degrees to starboard side and has yet to load 250 tons of cargo. There is space available in each side of number 3 between deck, center of gravity 6.1 meters out from the center line. Find how much cargo to load on each side if the ship is to be upright on completion of loading. So from the diagram we see that the list is theta, that is 2.5 degrees to starboard side. We have to load 250 tons. Let's assume W to be loaded on port side. On the starboard side will be 250 minus W tons. The distance is 6.1 meters on either side from the center. Center of gravity has shifted to G dash as ship is listed to starboard side, and the displacement 13750 tons is vertically down from point G dash. Now as we have seen earlier, tan theta is equal to G dash divided by GM final, that is tan of list, degree of list, is equal to G dash divided by GM final. Hence G dash is equal to tan theta into GM final. GM final value as given in the question is 0.75 meters and degree of list 2.5 degrees, thereby putting the values tan 2.5 degrees and calculating the values, we get G dash is equal to 0.0328 meters. Now in the end, if the vessel has to be upright, the moments on the starboard side and the port side should be equal. Thereby all the moments created by the weights on the starboard side of the center line is equal to the moments created by the weights on the port side of the center line. So now on the starboard side we have two weights acting, that is first the displacement acting with a distance of G dash from the center line, which we calculated as 0.0328, hence moment created 13750 into 0.0328 plus moment created by weight 250 minus W, that is 250 minus W into 6.1 equal to the moment on the port side by weight W, that is 6.1 into W. Now we solve this equation to get the value of W as follows: 451 plus 1525 minus 6.1 W is equal to 6.1 W. that is 1976 equal to 12.2 W. Thereby W is equal to 1976 divided by 12.2 is equal to 162 tons. That means we have to load 162 tons on the port side. Hence, cargo to be loaded on the starboard side is equal to 250 minus 162 tons is equal to 88 tons. Hence, we can say that a vessel which was initially listed 2.5 degrees to starboard, the weight 250 ton is to be divided in parts 162 tons on the port side and 88 tons on the starboard side in the number 3 deck, so as to bring the vessel to an upright condition. Let's now discuss condition number 3. The ship starts upright and ends listed. So let's discuss the example. A ship of 6,000 tons displacement has km 7.3 meters and kg 6.7 meters and is floating upright. A weight of 60 tons already on board is shifted 12 meters transversely. Find the resultant list. So the vessel is initially in upright condition. We have to shift a weight of 60 tons transversely to make the vessel listed and find the resultant list. So here, as in the diagram, we can see 60 tons is shifted over a distance of 12 meters, creating a list of theta degrees which needs to be calculated. Hence, once a list is created, center of gravity shift to point G1, thereby displacement acting 6,000 tons from the point G1. Thereby Gg1 is equal to small w, the weight shifted, into t, that is distance shifted, divided by w, displacement, that is 60 into 12 divided by 6,000 is equal to 0.12 meters, that is Gg1 is equal to 0.12 meters. Now we know that Gm final is equal to Km minus Kg equal to 7.3 minus 6.7 is equal to 0.6 meters, that is Gm final is equal to 0.6 meters. To calculate the list, the formula tan theta is equal to Gg1 divided by Gm final is equal to 0.12 divided by 0.6 is equal to 0.2. Hence theta is equal to tan inverse 0.2, which gives value of theta is equal to 11 degrees 18.5 minutes. Therefore, the list created by shift of 60 tons over a distance of 12 meters will create a list of 11 degrees 18.5 minutes. Now here in the question, as the direction of shift of weight of 60 ton is not given, either it is from port to starboard or starboard to port, hence we have to only calculate the degree of list, that is theta, and not specifying the direction port or starboard. Hence it is only theta equal to 11 degrees 18.5 minutes. Now let's move to another example. A ship of 8,000 tons displacement has km 8.7 meters and kg 7.6 meters. The following weights are then loaded and discharged. Loaded 250 tons of cargo, kg 6.1 meters and center of gravity 7.6 meters to starboard side of the center line, and load 300 tons fuel oil, kg 0.6 meters and center of gravity 6.1 meters to the port side of the center line. Discharges 50 tons of ballast, kg 1.2 meters and the center of gravity 4.6 meters to the port of the center line. Find the final list. Here the vessel has loaded some cargo and discharged some ballast, thereby creating a list, so we need to calculate the final list. So as in the diagram, 8,000 tons displacement with kg 7.6, meters along the center line, 250 tons of cargo loaded on the starboard side, kg 6.1 meters, and from the center line, center of gravity 7.6 meters, 300 tons of fuel loaded on the port side with kg 0.6 and 6.1 from the center line, and 50 tons of ballast discharged from the port side with kg 1.2 meters and center of gravity 4.6 meters from the center line. So now, calculating the GM final, we go about by making the three columns weight, kg and moment about the keel, putting the values 8000 kg 7.6, weight 250 kg 6.1, weight 300 tons kg 0.6, 50 tons ballast kg 1.2, plus sign for the initial displacement or the weights added, minus for the weights subtracted. Thereby final displacement is 8500 tons and final moment 62445. Thereby kg final is equal to final moment divided by final displacement 62445 divided by 8500 is equal to 7.35 meters. Now GM final is equal to km minus kg final. 8.7 minus 7.35 is equal to 1.35 meters. Now calculating change in shift of center of gravity, GG1 final. So calculating starboard moment is equal to weight added on starboard side 250 tons into 7.6 from center line plus 50 ballast removed from port side into 4.6 is equal to 1900 plus 230 is equal to 2130 ton meters. Moments on port side 300 into 6.1 is equal to 1830 tons meter. The ballast removed could have been written on the port side. The values would have subtracted from port moment. So now final moment 2130 minus 1830 is equal to 300 tons meter to the starboard side. Hence Gg1 is equal to final moment by final displacement. Final moment is 300 tons divided by final displacement 8500 is equal to 0.035 meters. So now we are required to find the final list, and the formula for that is tan theta is equal to Gg1 divided by Gm final. So we have the value of Gg1 is equal to 0.035 divided by 1.35 Gm final is equal to 0.0259. So theta is equal to 1 degree 29 minutes, which is the value of list, and the direction is to the starboard as the final moment is to the starboard side. Moving on to the last condition, ship starts listed and end listed. Let's see the example. A ship of 5000 tons displacement has kg 4.2 meters and km 4.5 meters and is listed 5 degrees to port. Assuming that km remains constant, find the final list if 80 tons of bunker are loaded in number 2 starboard tank whose center of gravity is 1 meter above the keel and 4 meter out from the center line. So as we can see in the diagram, the displacement is 5000 ton, which is to the port side from point Gg1, as the vessel is already listed 5 degrees to the port. Kg is given as 4.2 meters initial and km 4.5 meters. Km remains constant throughout, and now 80 tons is bunkers loaded in number 2 starboard tank, that is 1 meter above center of gravity from 4 meters from center line. So let's see now, Gm initial is equal to Km minus Kg initial equal to 4.5 minus 4.2 is equal to 0.3 meters. Using the formula for list, tan theta is equal to gg1 by gm initial. As in the diagram, we can see gg1 is equal to gm initial into tan theta, that is 0.3 into tan 5 comes to 0.02625 meters. Now calculating gm final, we put the weights kg and moments about the keel. We get final displacement 5080, final moment 21080. Therefore, kg final moment divided by final displacement 21080 divided by 5080, 4.15 meters. Hence, gm final is equal to km minus kg final, equal to 4.5 minus 4.15 equal to 0.35 meters. So now we have gm final, that is for the final condition, and to find the final list we need to calculate final gg1. For that we need to calculate the moments on the either side to see the value of gg1. Hence, calculating gg1 final, let's calculate starboard moment is equal to 80 into 4 is equal to 320 tons meter. Port moment 5000 into 0.02625 is equal to 131.25 ton meter. This is because port side the displacement was already there with the list, and starboard side the new weight 80 tons is loaded, that is the bunkers. Hence final moment is equal to 320 minus 131.25 is equal to 188.75 tons meter to starboard. As starboard moment is bigger, the list is to the starboard side. Now gg1 is equal to final moment divided by final displacement is equal to 188.75 divided by 5080 is equal to 0.0372 meters. So the formula for the list, again tan theta is equal to gg1 divided by gm final. So tan theta is equal to gg1 0.0372 divided by 0.35 is equal to 0.1063. Hence theta is equal to 6 degrees 4 minutes to starboard. That means the final list will be 6 degrees 4 minutes to the starboard side after 80 tons of bunker is loaded in number 2 starboard tank. So now let's move to next question. A ship of 11,004 tons displacement listed 4.5 degrees to starboard side and has km 10.5 meters, kg 10 meters. The ship loaded 400 tons of fuel in number 3 double bottom tank port side. Kg of that 0.5 meters, Cg 6 meters from the center line, and discharged two cases each 45 tons from twin deck, hole number 2 port side, Kg 8 meters, Cg 10 meters from the center line. Find the angle of list. And if double bottom tank port and starboard side Cg 7 meters from the center line are empty, find the amount of water ballast need to be loaded to bring the ship back to upright position. So here is the solution.